Mr. Schmidt, and this is our first section of pre-AP pre-calculus. We're going to classify numbers. Real numbers, you see up at the top here, real numbers actually include irrational and rational, so that title probably should have been moved over a little bit. And then we have what are called imaginary numbers. Okay, what I had down below is a list of numbers, and then I put them up here, but I guess I can just explain it by looking up here. Now, we actually have an extra circle here. This is actually a 0. Okay, we have an extra circle here for the natural numbers, but we're not going to worry about those. So I took out the word natural in there. We're just going to include a 0 as a whole number. 16 is also a whole number. Those are numbers, obviously. You should know what whole numbers are, but the key is they do not include negative numbers. They do include 0, obviously, and any positive whole number is under the whole numbers. Now, integers includes these. A 0 is an integer, 16 is an integer, but also this weird looking one here, negative 12 over 3. Well, you all know that's negative 4. So that is also an integer. So any whole number that is positive or negative is an integer. Now you see in the rationals, I have 3 others outside here, okay, that fall under rational, but they are not integers or whole numbers. Well, pretty obvious when you see we got a couple decimals here. When you have a decimal that terminates or ends, that is a rational number. So 34.7 is a rational number. 28.3, you'll notice, does not terminate, but it repeats. So therefore, it is also a rational number. We'll get to irrationals in a minute. 14 over 11, any fraction is rational. So 14 over 11 would be rational also. So fractions and decimals that either repeat or terminate are rational numbers. Now, irrational would be square roots that are not perfect squares. See, I could have had like square root 16. Well, that would have fallen under whole numbers because it was square root 16 works out to be 4. 4 pi, well, just know pi is always irrational. Doesn't matter what you put as far as a number in front or divide it by. Anytime you have pi, that's going to be irrational. Now, here's an interesting one. This is a continuing decimal, but notice it's not repeating. If this would have said 2525 or 2424, then we would have put it over here into the rationals. But even though we see a pattern to it, that doesn't matter. It's not going to be rational. We won't be able to turn it into a fraction. See, we could turn this into a fraction. That would be 28 1/3. Okay? Now, imaginary numbers always have the I. Whenever you have the I, it's an imaginary number, 21i and then 4 plus 3i. Now, the square root of a negative number is imaginary also, and that's actually what the I stands for, is square root of negative 1. So this would actually, officially, you would put an I out front. You'd take that negative sign out front, put an I there. We wouldn't have the negative anymore. The I would take care of that, and we would have I square root 14. But anyway, that is our first section. Talk to you later.